Hello,
Good evening,
everyone.
everyone. Yeah. On behalf of Cheenta Academy and the Lokesharananda I Foundation, I welcome you all to today's Leadership Final Project presentation. We are very proud to showcase a student led innovation that combines healthcare, artificial intelligence, and social impact, an initiative that called CATSCAN. Before we begin, let me introduce the brilliant team behind this project. We have with us Yashvardhan, Sarvesh, and also there is Han, but he is not present. So, Yashvardhan, it's over to you.
Thank you, ma'am. So, hello, everyone. Today, we want to show you something we've built, something simple, something powerful, and something we believe can change lives. This is CatScan, a mobile app that brings early cataract detection right into the hands of rural people. So, we'll start with the business problem and understand what cataract really is. And then we'll talk about the solution, how it was built, our neural network, our work with doctors and ophthalmologists, and more about the app's limitations and our future work. Let's begin with the business problem. So, in many remote villages across West Bengal, getting a cataract checkup it's an event, not a quick visit. People walk long distances, often for hours, or rely on unreliable transport. And when they finally reach a hospital, half the day is already gone. For many, this is simply not sustainable. Add to this the lack of local eye care facilities and trained personnel. The result? Early detection almost never happens. People live with worsening vision until it becomes severe, until it becomes blindness that could have been prevented. And hospitals, already overloaded, end up handling only the advanced cases. So, what is cataract? A cataract is the clouding of the eye's natural lens caused by clumping of lens proteins. This scattering of light reduces clarity, color perception, and low light vision. There are many symptoms like blurred vision, faded colors, and glare sensitivity. And the important part is this: early cataract changes are visible in eye photographs. This creates a real opportunity for AI based screening using images focused on the pupil and anterior lens. Cataract progresses through four stages, and the earlier they are detected, the easier they are to treat. This is exactly why early detection is crucial. So, the problem is clear. People need early screening, but they cannot reach hospitals. Hospitals are overloaded, but we can't bring equipment to every village. What we need is a simple, portable, reliable screening tool that works anywhere. So, our objectives are an app that has easy data management. And so that's exactly what we've done here. We've built an app with Python and a neural network with TorchScript that satisfies all of our objectives. Allow me to introduce CAT-SCAN. What if early cataract detection didn't require a hospital, just a smartphone? That is exactly the idea behind CAT-SCAN. A volunteer takes a photo of the eye, and our AI model returns a prediction in seconds. No internet required, no expensive machines, no specialized training. CAT-SCAN turns a simple eye photograph into instant AI-powered insight, has guided eye image capture workflow, pupil-centric cropping for accuracy, on-device AI cataract detection, and many more. So, how did we build this? We began by designing a clear, structured system architecture, a flowchart that mapped every step from image capture to pre processing to prediction to storage. This blueprint helped us build the app in a controlled, organized way, ensuring that every component fit together cleanly. We built CAT-SCAN collaboratively on Visual Studio Code LiveShare. And as you can see, each aspect of the app was handled by a different member. The UI, UX design, and the development of the neural network by Ahan. the development of the cataract prediction database by myself, Yashwardhan, and the image capture and upload pipelines by Sarvesh. So, piece by piece, we assembled an app that's not only functional, but intuitive and reliable. Over to Sarvesh to talk about the features of our app.
Yeah, thank you, Ashwardhan. So I'll be talking about our app features and how it works. We first have like a register screen in which new users can register by using their Aadhaar and all, because it provides like a unique username for them. And then we move on to the sign in screen or the login screen. Here, the users will log in using their Aadhaar and phone number. This will send them to view the profile screen. This will show their details and displays like the other screens which they can go to. First, it shows the database screen. This will show their previous visits and their previous records in their previous visits. Then they can visit the capture image screen. In this screen, the user can capture the image of the eye. There are two options which they can do. They can upload an image from gallery or they can take an image from camera, and then they can readjust or retake the image according to their wish. And then we have the center pupil screen. In this screen, it's very crucial that the pupil is centered so that the AI model can give an accurate prediction. So we have some options which let the user center the pupil, and it can let them reset if they want to, if they have made a mistake, and they can also convert the image into grayscale so that it avoids complexity. Next, after the pupil is centered, we move on to the database. We can save this image to the database, and the user can make any notes of like the symptoms. Like if they're having blurred vision, then they can make the notes in the notes section of the saved database screen. After that, the AI model will display its result or its prediction. It only has two viable answers. One is cataract and one is non-cataract. And then from this, they can confirm the results and then move on to the dashboard screen again. In this screen, they'll be able to look at their previous visits and save this as one of their visits. Yeah. And then they can again view any of the visits. They can view the notes of each and every of the visits if they like. And then if the condition is getting worse, then they might consider taking a health checkup. Over to you, Yashwant.
Yeah, so now we'll have a video demonstration of how our apps works, where you can clearly see every screen and every interaction the user makes with the app and how it really works. So as you can see here, we're uploading an image from our device, and then we move on to the cropping stage where we crop the image so that we only have the pupil, because we don't want the rest of the image to interfere and uh, give us an inaccurate prediction for the AI model. So as you can see, we've clearly cropped the pupil and it has predicted that this person has cataract. We can enter our notes here, annual checkup, and save it to the database. And as you can see here, you can select multiple images. It takes you back to the dashboard where you can select more images and crop them. Yeah, it's simple UI and very easy to use. Anyone can use it, and you can say all these images will be saved in the database, as you can see here. Now, let's talk about the neural network. At the heart of CAT-scan is our AI model, a lightweight CNN optimized specifically for mobile devices using ThoughtScript. It doesn't need the cloud, it doesn't need a server. Everything runs right on the phone. This gives us three core advantages: speed, accuracy, and accessibility. To ensure real world reliability, we train the model on clinically annotated images. After 10 epochs, we achieved 96% training accuracy, 93% validation accuracy, and impressive F1 score of 0.92. Fast, reliable, and robust. Throughout development, we met with regularly with ophthalmologists. Their feedback shaped our design decisions, validated our predictions, and ensured CAT scan aligned with real clinical needs. These consultations kept the project grounded in medical reality and not just technical possibility. And throughout this journey, the only result is not the app that we've built, but also a lot of the things we've learned as we've worked on this app and together with the other members in our team. We've understood the problem, optimized the business needs, and created a user centric design, aligning all the solutions to the needs. The technical skills we've gained, like data management, UI prototyping, system design, prompt engineering, and as well as using VS Code Live Share, and working with Kiwi and SQL for database backend. We've also learned collaboration, making readable and more engaging slides, all throughout the process of working on this project. Of course, CAT-scan is still early in its life cycle. It has limitations. As you can see, it only gives a binary output. There's no grading yet, so we can't really tell what stage of cataract the person has. And of course, the image quality significantly does affect performance. The data set needs more diversity. Our data set currently is quite limited, and our app has not yet been clinically validated. So, in the future, these are the things we aim to work on: adding multi stage grading, introducing guided capture with feedback, eliminating noise in the image due to the image quality, expanding the dataset across regions, and conducting full clinical trials. These are honest constraints that we're actively working to overcome. Now, imagine the year is 2028. Every volunteer carries CAT scan. Screening happens in seconds. Cataract is detected in mere seconds. Fewer people lose vision simply because they live far from a hospital. And all of that begins with what we've built here today. Thank you for your time and your attention.
That's really great, Yashvardhan, Sarvesh, and also Ahan. He is not here. I just want to tell you that I was in the journey with you for the past 6 months, and the journey was obviously very I have learned so many things from you. So thank you so much, Yashvardhan Sarvesh, and I wish you all the very best for your life, for your education.
Thank you, ma'am. Thank you so
I
much.
wish you a
Thank
great
you,
life
ma'am.
ahead. Thank you, guys. Thank you for joining. If you have some comments, please in the put it on the comment section. We will be really happy to answer it. Thank you, everyone, to join the session. Bye.